Okay, everyone, welcome back to Backend Magang. Stay humble and keep the excitement to learn like a newbie intern. Yeah, before we start, as usual, I would like to thank you for all of you for supporting me by subscribe, like, and share. Yeah, thank you very much. And yeah, in this video, we will take a high-level look at Kubernetes. So yeah, Kubernetes, often called KX, was developed by Google based on their experience running containers at scale in production. And today, it's an open source project and is considered one of the best and most popular container orchestration tools out there. And yeah, sorry, oh my neck. Yeah, we will aim to understand Kubernetes from a broader perspective. And to do that, we first need to break it down into two parts. They are containers and the orchestration. And once we get a good understanding of this, we will be in a better position to appreciate what Kubernetes brings to the table. So, yeah, without further ado, let's get it on.
Please like, share, comment, and subscribe.
Okay, for the containers and Docker, let's first understand what containers are. And for that, we will take a closer look at Docker, which is one of the most widely used container technologies. Yeah, anyway, we will go over why Docker is important and how it can help you. And yeah, let me share how we need Docker. Okay, so imagine in one of our projects, we had to set up a microservices application using various technologies. For example, a backend services written in Golang and a database like MongoDB and PostgreSQL and caching tools such as Redis and yeah, etc. Okay, it sounds straightforward at first, but we quickly run into several challenges. The first one is compatibility issues. Yeah, its component had its own system requirement, so we had to make sure the operating system support every component and its specific version. Sometimes a database work only in one OS version, while another component work in a different one. This constant back and forth to find the perfect fit for all the components was incredibly frustrating, of course. So it's often called the matrix from hell. And the second one is dependency conflict. So some components require a different version of the same library, which makes things worse. And the third one is the environment setup for developer. So whenever a new developer joined the project, it took forever to set up their environment. So yeah, everyone had to manually configure their system to match to match the right OS and software versions. And the last but not least is inconsistent environments. So yeah, developer often use different operating system for development, which led to the classic problem: it works on my machine. Okay, what ran fine on one machine often broke in testing or production environments. Yeah, that's why we need a solution to simplify all of this. That's when we have to use Docker. And how Docker helps is Docker allow us to run its component in its own container. A container is like an isolated environment where you can include only the libraries and dependencies that the component needs. So instead of worrying about system level compatibility or dependencies, we just had to configure a Docker container once. Now every developer could start working immediately using a simple Docker run command, no matter what operating system they were using, as long as Docker was installed. Okay. Yeah, container. What are containers? Containers are isolated environments that have their own processes and services, include their own networking interfaces, and have their own storage mounts. So they are similar to virtual machine, but much lighter because containers share the same OS kernel. Yeah. Let's compare a Docker container with traditional virtual machine or VMS. So with Docker, you have the host operating system, an example Ubuntu with Docker installed, and containers share the host operating system kernel, making them lightweight and fast. And containers only include the app, its dependency, and libraries. And with virtual machine, each VM includes a full operating system, making them much heavier, and VMs take longer to boot, so minutes versus seconds for container. And VMs offer full isolation, while containers have shared resources like the kernel. So for a real-world example, okay, to better understand this, let's back at the typical example that I told before. So imagine you are building a microservices application using Golang. Alongside it, you need MongoDB, Postgres, Redis, and etc. So with Docker, you would search for pre-built Docker image on Docker Hub for MongoDB, Redis, and etc. And pull those images using a simple Docker pull command. And then after that, you have to configure and run each component in each container. That's the point. So yeah, now suppose you want to run multiple instances of your Golang web server. All you need to do is spin up additional container and set up a load balancer in front of them. If one container crashes, you can simply destroy and yeah, you can simply destroy it and start a new one in seconds. And yeah, it's important to distinguish between image and container, of course. So image, yeah, think of it as a template. It's the base you use to create container, and container is the running instance of an image. So it's complete with its own processes and environment. Yeah. Yeah, before Docker, developer would write code and hand it over to the operation team with setup instruction. The ops teams then had to figure out how to configure the environment, which often led to delay and frustration, of course. So with Docker, developer create a Docker file, a script that describes how to set up the environment, and from this Docker generates an image. This image can then be run on any system with Docker installed, ensuring consistency across development, testing, and production environments. So, in short, Docker has simplified and streamlined the development and deployment process, allowing teams to focus on building and shipping great application. And then the container orchestration. Okay, yeah, let's talk about a container orchestration. So, how do you actually run this in production? And here's the real kicker: what if your app isn't alone? What if it needs a database, messaging service, or even other backend services? Yeah, kind of like a stringy sibling that cannot function with that company. And yeah, let's not forget about scaling. Imagine your app goes viral. Yeah, it's good for you. And suddenly, thousands of users flood in. How do you scale up quickly to meet demand? And what happens when the hype dies down and you need to scale back before your world cries for help? Enter container orchestration. This is where a platform steps in to manage all the heavy lifting like connecting containers, scaling up or down based on traffic, and making sure everything runs smoothly. It's like a really organized party planner for your container. So yeah, why is container orchestration yeah so cool? Yeah, the first one is high availability. Your app won't go down if a server crashes. Why? Because there are multiple copies of your app running across different nodes. And after that, the load balancing. User traffic is distributed across your containers. No container get overwhelmed like a waiter handling 10 tables alone. And then seamless scaling. It's yeah, more users, no problem. Kubernetes spins up more app instance in second, and when traffic slow down, it scale back down like magic, but not there. And then node scaling. So run out of hardware, just add more nodes without stopping your app. You are basically expanding your real estate without telling the tenants to move out. And the last but not least is declarative configs. So you can manage everything with simple configuration files. It's like writing down your app wish list, and Kubernetes make it happen. Yeah, in short, Kubernetes is a powerful tool that orchestrates the deployment and management of hundred, yeah, or even thousand of containers in a cluster. It keeps your app happy, healthy, and running smoothly, kind of like a personal trainer but for software. Yeah, yeah, now imagine your application is now highly available as hardware failures to not bring your application down because we have multiple instances of your application yeah, running on different nodes. And the user traffic is load balanced across the various container. Yeah, as you can see on my screen, the user, the load balancer, the orchestration, yeah, and then the nodes. Yeah, nah, when demand increases, deploy more instance of the application seamlessly and within a matter of seconds. And we have the ability to do that at the service level when we run out of hardware resources, scale the number of underlying nodes up or down without having to take down the application, and do all of this easily with a set of yeah, declarative object configuration files. And that is Kubernetes. So yeah, the container orchestration technology used to orchestrate the deployment and management of hundreds and thousands of containers in a cluster environment. Yeah, before we head into setting up a Kubernetes cluster, it is important to understand some of the basic concepts. So now let's start with nodes. Okay, the nodes. Yeah, before we dive into setting up a Kubernetes cluster, it is important to get familiar with some basic concepts. Trust me, understanding this upfront will save you from scratching your head later when all the fancy Kubernetes terms start flying around. Let's kick things off with nodes. So yeah, a node is just a machine, physical or virtual, whatever, where Kubernetes is installed. Think of it as a worker bee because this is where Kubernetes does its magic and launch your container. The fun fact is nodes were actually called minions back in the day. So if you hear someone throw around that term, don't panic. They are not talking about the yellow guys from the movie. And now, what happens if the node running your application fails? Well, spoiler alert, your app goes down with it. It's like putting all your eggs in one basket and then accidentally dropping the basket. After that, the cluster. So here's the deal. You cannot rely on just one node. That's like having only one waiter in a restaurant on a Friday night. It's a disaster waiting to happen. So enter the cluster. A cluster is basically a group of nodes working together like a team. If one node decide to take a nap, aka fails, no worries. Your application is still up and running on the other nodes. And plus, Having multiple nodes mean they can share the workload. It's like having extra waiter. No single node is overwhelmed, and everyone say happy. Well, except for that one lazy node taking its break. And yeah, all right. So now we've got ourselves a cluster. Yeah, great. But here's the big question: who is in charge of running this whole operation? Who keeps track of all the nodes in the cluster, and who monitors their health, and when a node decides to bail on the job, or fails, who makes sure its workload gets moved to another node like a hot potato. Yeah, that's where the master comes in. Think of it as the brain of the cluster, the one calling all the shots, keeping everything organized, and ensuring the container is left behind. So basically, the master, is the boss. Okay, the master. So yeah, the master is just another node with Kubernetes installed, but with fancy title and and way more responsibilities. It's like that one friend in a group project who actually does the work. Yeah, the master keeps an eye on all the nodes in the cluster and handle the orchestration magic, making sure container get deployed, move, or scale across the worker nodes. And in short, it's the conductor of the Kubernetes orchestra, ensuring everything plays in harmony. Yeah, after that, the components. When you install Kubernetes on a system, you are not just installing one thing, you are setting up an entire team of components. It's with its own role. Let's break it down so it makes sense. Yeah, the first we have the API server, the front desk of Kubernetes. So everything talks to the API server, user, management tool, and even the command line. If you want to interact with the cluster, this is your gateway. And for the next is the etcd store. So yeah, for the etcd, think of etcd as Kubernetes brain and memory. It's a distributed, reliable key value store where all cluster related data lives. And when you have multiple nodes and multiple master, of course, in the cluster, etcd makes sure all that information is stored and synced perfectly across nodes. It's also the peacekeeper, implementing logs to prevent a conflict between master. So yeah, basically etcd ensure everyone's on the same page. After that, we've got the scheduler. Imagine the scheduler as your Kubernetes project manager. It finds newly created containers and decides which node they should run on. Yeah, got work. The scheduler hands it out. And now we enter the controller, the brain of the operation. They are ones constantly watching the cluster. If a node, container, or endpoint goes down, the controllers are like, no worry, I got this, and spin up new containers to keep things running smoothly. Here's where the container runtime comes in. This is the software that actually runs the containers. For more setup, that's Docker, but Kubernetes also plays nicely with other runtimes. So yeah, finally we meet the kubelet. This little agent runs on every node in the cluster, acting like the Kubernetes babysitter. It ensures that all containers on the node are running as expected and doing what they are supposed to do. So there you have it, from scheduling container to watching over nodes. Every component plays a critical part in keeping Kubernetes up and running like a well-oiled machine. Okay, for now we will talk about the master versus worker nodes. So far, we've covered two types of server, master and worker, along with the components that make up Kubernetes. But how do these components actually get distributed across the servers? Yeah, in other words, how does one server become the master and the other one the worker, or as it was once known, yeah, the minion? Yeah, well, the worker node is where the containers live, like your beloved Docker containers. So to run this container, we need a container runtime install, and that's where the container runtime fits in. In this case, that's Docker. Yeah, but there are other options too. But in this case, we will talk about Docker, only Docker. So on the flip side, the master server hosts the kube epi server, which is what officially makes it the master. So the master is the one calling the suit, and yeah, it's where the Kubernetes management magic happens. Yeah, the worker nodes have the kubelet agent. The kubelet job is to interact with the master, and yeah, provide health updates about the worker node, and execute any action requested by the master. So it's kind of like the worker bee reporting back to the hive. Yeah, all data collected from these nodes is stored in a key value store powered by etcd, as we mentioned earlier, of course. And yeah, the master also has the control manager and scheduler. There are more components, but we will keep it simple for now. Yeah, why are we going through all of this? Understanding these key components of the master and worker nodes will help us install and configure the right parts when we are setting up our Kubernetes infrastructure. So it's a solid foundation for the next step. Yeah, finally, let's take a quick look at one of the command line tools you will be using a lot, the CTL Cube command line tool, also known as Cube Control. So the Cube Control tool is your go-to for deploying and managing application on your Kubernetes cluster. It's also what you will use to get information about the cluster, check the status of nodes, and manage pretty much everything else. For example, the Cube Control run command is used to deploy an application on the cluster, and the kube control cluster info command gives you the cluster details, and the kube control get nodes command lists all the nodes that are part of the cluster. Okay, that's all we really need to know for now. So we will dive deeper into using kube control as we go along, but for now you've got the basics down. Yeah, if you found this video helpful, don't forget like, share, and hit that subscribe button. Turn on the notification so you never miss out. You never miss out on our future videos. Let's grow and learn together, one container at a time. And once again, thank you very much. See you in the next one. Cheers, Backend Maga.